So we'll start today's session. This would be our second lab session where we are actually going to start doing a lab on packet tracer, and immediately after you finish your lab, you will show me your lab exercise. It's 7 minutes past 2 and we have 90 students. Hopefully others will join us soon. I would like to start with our lab 2 introduction. So what I'm going to do is, before we actually do the lab, I'm going to show you, I'm going to go through the lab 2 content. The same thing that you can access on NetAcad, I'm going to go through quickly with all of you. Okay?
Sir,
Yes?
can you help me with the login for the Cisco?
Who is this? Tanbir, yes, I will. Don't worry.
Ayman.
Who is that? Ayman? Hamada?
Yeah.
Yes. So there are 3 of you. I will create a login for you. Okay?
Okay. Okay, thank you, sir.
Thanks. For now.
Okay, sir.
Okay. Let's go through the concept of using a basic switch and how do you configure it. Okay. This is going to be the main lab for today. So these are some of the things we are going to study. Okay. Accessing a switch and how we configure it. Okay. When you access a switch or a router, for that matter, you are supposed to learn a command line commands, which are inter-networking operating system commands. Okay. Usually, when you access a hardware device, there is a shell that allows you to communicate. That shell can be a command line interface or graphical user interface. Okay. And it allows you to, it goes through the kernel and then through the hardware and allows you to communicate through a series of commands with your hardware. So what we are going to use is our iOS to communicate to our router as well as to our switch. So we have a graphical user interface for many of the hardware devices we use, but for accessing networking devices, it is always a command line interface. Okay, and you have to learn the commands if you want to configure your router or your switch. An example of a command line interface is your command prompt in Windows or your Linux prompt in a Linux system. Okay. Similarly, if you want to access your Cisco devices, your routers and switches, you have to know your command line commands. And through this course, you will be learning some of them. First things first, you have to connect your device, be it router or switch, to a monitor to see the output. If you don't do that, you cannot see what commands you're typing. So how do you do that? We use a console cable. The blue cable over here is a console cable. Okay. Now on packet tracer, we don't have to do that. On packet tracer, we don't need to use a console cable because on packet tracer, everything is automatically shown to us, as I will show you later. So no big deal. But in the real world, when you're using your device, router or switch, there is a connection, which is a port shaded with blue, it is for the console cable. So this end will be connected to the router or switch, and the other end will be connected to your COM port. Now, some of you may say, hey, my PC does not have a COM port. The last time we had a COM port was back perhaps 10 years ago or less. So no worries. We also have special devices, adapters that convert COM to USB. Okay. Now that is the reason when you go to our lab at Curtin, when you go to the BTech lab, you will see all the computers we have a COM port behind them so that we can connect the console cable. Okay. You can also access your router or switch by using the network. You can use a software known as Telnet to access it through the network. Or you can also use this another software to make sure that your access is secure. Okay. Now, how do we access in the lab? By using a software known as PuTTY. Okay. Mention your COM port and your port, and then you can access it. It's very easy. But then you have to use the console cable. Now, I told you, in Packet Tracer, we don't do that. We don't need that. We also have certain softwares like PuTTY, I told you, to allow us to connect. You also have a secure software, like over here, TerraTerm, that allows us to connect from the network. For example, sometimes you, as a network administrator, you don't want to go to the actual device and use the console cable. What you want to do is you want to sit at your office and access the router or switch, which is, for example, 5 buildings down. So in those cases, if you have a viable network connection, then you can use perhaps a secure shell or telnet to access it. Okay. An example is over here. Now, let's go and have a look at our iOS commands. Okay. When you switch on your router or your switch, the first thing you see is this. Now, in order to do anything substantial, you have to go to the privilege exec mode. By default, you are always in the user exec mode. In order to go to the privilege exec mode, you have to type enable. Okay? You have to type enable. I'm going to open my Packet Tracer so that I can show you some of these. So if I have a Packet Tracer software, and let's say I take a switch and put it here, I open the switch, and this is my command line interface. You see the switch is loading. So in these cases, I don't need a console cable. Okay. If you go to the cables, you can see the console cable is right here. But in this case, we don't need it because we can directly access our switch operating system. So going back here, there, you can see the switch prompt. Okay. So how do I access it? Very simple. I say, in order to go to the privilege exec mode, I say enable, or the short form, en. I exit again. There, en. So all commands have got a short form. Okay, so now you go to the privilege exec mode. Okay. So the same goes for a router. You can also configure by typing conft. You can also enter other commands like line configuration, interface configuration. All these things will be going through, and I'll be showing you how to do it. So how do we go to configure terminal? We have to type configure terminal. How do we go to line configuration? We have to type line console 0 and so on. Okay. For example, here, what I'm doing is I'm saying that my switch, I want to go and access my fast Ethernet 01. So I type interface fast Ethernet 01. Once I type this, then that interface will be activated. Now I can give an IP address to that interface. Okay, no worries. I'll be showing you all how to do this. Now, what does a command look like? The command structure consists of keywords and arguments. A command might require one or more arguments, okay? And there is a structure in which NetAcad shows you this. There is a convention they follow. As you have, if you have gone through the NetAcad guide, you will be shown how it is. My dear students, you have to do a lot of self-study for this. You know, those chapters on NetAcad, you have to study and prepare for your lab. There is also a ping command where you type ping IP address, which you're going to do today. Okay. So some of the commands that you're not so sure of, you can use the question mark, and that can give you more information about that command. Okay. And you can also use hotkeys. Like I remember, instead of typing the whole enable, I just typed en, and it will accept. Similarly, there are some commands you can just you can just type the shortcut. Okay, I'll show you an example. Look here again. For example, I want to go to my configure terminal. Configure terminal. Okay, there. You see, now it has gone to config. Okay, now instead of typing the whole command configure terminal, let's just exit. What I do is I just type conft there. So we got a lot of shortcut commands like this. Okay. Yeah. So these are some of the keystrokes and shortcuts that you can learn. So some basic device configuration. How do you configure your device? Very simple. You go and type configure terminal. You go into the configuration, and then you can change your device setting. For example, here we are changing the host name from the default switch to whatever name we want. Okay, we can make those changes. You can also give password to your devices. Now, I encourage you not to do that while you're on Packet Tracer, but when you're actually on using real equipment, perhaps in your working environment, then you do it. In the lab as well, when we are in the lab, I tell my students, please do not give a password for your devices, because it will be always difficult for other students. But if you are giving a password, just remember 2 passwords, which will be easy to crack, either Cisco or class. That's it. Don't give a password that later on you won't be able to access your system. Okay. There we are giving a password. This password, for example, when we want to go from exec mode to privilege exec mode and so on. If you want to go to your exec mode, you can give a password. If you want to go to your privileged exec mode, you can go and give, for example, enable secret, password, and so on. Okay. In the lab today, actually, I've given you the guide how to give a password. Well, you can practice that at your own time. But what I want to see today is you follow that topology. Which one I'll show you. For now, let's just go through this. You can also give a password if you want to access your switch or your router through the network by using SSH or by using Telnet. That one, the password will be different. You see, for going to your exec mode, the line console password is 0. For going to the privilege exec mode, then it will be enable secret password, whatever password you give here. But if you want to access through network, then you have to say line VT 015. Okay. You can also, whenever you start your system, whatever system is running, you can type show running configuration. You can also save your your new configuration as the running configuration. Okay, there, saving configurations. Show startup config, show running config, and you can also, for example, type erase startup configuration. Okay, and in order to make the changes permanent, you just type reload. We'll be doing these things, so don't worry. You can also save whatever you're doing, all your configuration, to a text file. Okay. You can do a logging of all your changes. Now, these are not so important when you're working on your packet tracer, but when you're actually a system, a network administrator, then perhaps these things will be important. And it's all about giving IP addresses to all our devices. Okay. If it's a computer, you have to give an IP address. If it is a port of a switch or a router, you have to give an IP address. So here, this is an IP version 4 address, okay, consisting of an IP address and a subnet mask. Now, if you forgot, I'm going to remind you this subnet mask. Why do we have a subnet mask? This subnet mask means my IP address consists of 24 portion, which is network address, and 8 portions, which is the host address. So this can range from 1 until 255. So you have an idea of how many computers you can add in this network, from 1 until 255. Okay. Now you may ask, what is default gateway? Default gateway is how you go out of the network. In other words, default gateway is your router's address. Okay. Now, I don't want to give you so much information that, you get overloaded. So we go a little by little. You can also give an IP version 6 address. You will be studying that. IP version 6, instead of 32-bit, it's 128 bits. Okay. And it has got usually 64-bit for host and 64-bit for network. Okay. And it doesn't matter if it's higher case or lower case. Okay, we'll be going through that as well. So usually a switch, what we're going to use today, a switch has got 24 ports. It has also got gigabit Ethernet access for connecting a switch with another switch. Configuring IP address on a PC, it's very simple. You go to the PC and configure the IP address. You can also select obtain an IP address automatically. When you do this, then your PC will communicate with a DHCP server. You're going to learn this. How do I configure a DHCP server? Either a router can be your DHCP server, or perhaps a computer or some other device. We'll be learning this as well. how to configure a device to be a DHCP server, which will automatically give IP addresses. No need to individually give IP address. Okay. Here, I am giving an IP address to my switch. I'm creating a VLAN, my default VLAN 1, and I'm giving an IP address to my VLAN 1. So this will encompass if you look at this diagram, this will encompass all the ports. Rather than giving individual IP addresses for all these ports, your VLAN 1 IP address will cover everything. See, you can do this. Okay. You can also give individual address to your ports if you want. So what I want to do is now.
Sir, can we access these slides from Moodle or they are on the site?
These slides are the same things that you access on your NetAcad.
Okay.
You know, when you go from chapter 1, chapter 2, they are the same thing, except now they're in slide format. No difference.
Okay. Thank you.
Yeah. Now what I'm going to do, I'm going to show you your first lab. Okay. Let's close this. Go to your first lab. There. Your first lab is already on Moodle. I would advise you to open it. This is your first lab, okay? And this is the topology that you have to do today. I have a PCA connected to a switch. What kind of connection is it? Straight through cable. PCB connected to a switch known as S2. What kind of connection is it? It is straight through. And then a switch is also connected to another switch. So this is the topology that you have to create today. You have to do it on your own and then show it to me. But no worries. I will, since this is the first lab, I'm going to show this to you. Okay? How to do it. So what will be the IP address for PCA? It's right over here, 192.168.1.10. What will be the IP address for PCB? 192.168.1.11. Now, rather than giving IP address for all the ports, remember how many ports we have over here in this switch? 24. Rather than giving an IP address to all the ports, I'm going to just create a VLAN 1 for this switch and give IP address 192.168.1.1. Similarly, rather than giving an IP address to all the ports for my switch to, I'm going to give an IP address 192.168.1.2 with the relevant subnet mask. Now observe, all the subnet mask is the same. And the IP address is all the same. The only part is different is the host portion. Can you see? 1, 2, 10, 11. Okay, the network portion is the same, but the host portion is different. Okay, so remember, that's why I told you all of them, that means they are in the same network, because the network portion is, the subnet mask is the same. That means all of them are in the same network. Same network, that means just a switch. You don't need a router for this lab. Okay, router is used to connect a network having different subnet masks or different IP addresses. Here, it's the same network, same subnet mask. Okay. Sometimes I will keep repeating what I'm telling you so that, you know, it really sinks in. Now, in this lab, you know, the commands, how do I give an IP address to my, how do I create a VLAN and give an IP address? If you scroll down, everything is over here. Okay. If you scroll down there, I've told you have to type enable configure terminal. You can change your host name to S1, and you don't need to do this part. You can do it later. Password and all, you can do it later. This is the part which is important. This part, okay? So I'm accessing my S1 interface VLAN 1. So it will change the interface to VLAN 1. Then I give a IP address to my VLAN 1. Remember, VLAN 1 is a logical address. It doesn't really exist. You're just creating a logical address and you're giving an IP address with a subnet mask. And then you have to type no shut. When you type no shut, press enter, then it will update the changes without switching off the switch. Okay. MOTD is message of the day. If you want to have a message of the day on your switch, you can implement it. But long story short, I want you to give an IP address to all the devices. And once you have done this, then do a ping. Okay. So I'm going to do this for you on Packet Tracer. I want you all to observe to see how it's done. Okay. Let me just go through these IP address. So the first switch is VLAN is 1.1. The second switch is called S2 and is .12. And this will be my PCA IP address and PCB IP address. Okay. So this is my topology. So let's go to my packet tracer. Okay, here's my packet tracer. What I'm going to do is I'm going to delete the old one. Delete. Yes, I want to delete it. So create a new structure. Let's start with our computers, a generic computer, one over here. This is called PCA. PCA, correct? Given IP address, IP configuration is 192.168.1.10. Subnet mask, yes, 255.255.0. No need to give a default because there's no router in this topology. So that's it. I just created my PCA. Now I'm going to create my PCB. Here's my PCB. Again, click here, go to configuration, change the name to PCB. Okay. Then go to desktop and IP configuration, give an IP address 192.168.1.11. Give your subnet mask, which is automatic. There, I just created my PCB. Now, next is the wiring. But before that, let's look at the switch. I take a 2960 switch, one over here and one over here. Okay, two switches. So let's go to the first switch. If I go to the command line interface, there, the switch has just started. Before giving the configuration, what I'm going to do first is I'm going to do the wiring. I go here. Remember, the cable I'm going to use is a straight through cable. So I'm going to connect the network interface card, which is the PC's fast Ethernet 0, to the, well, it says over here that you have to connect to, what does it say? PCA, you have to connect to fast Ethernet 6 on S1 and fast Ethernet 18 on S2. So we follow the exact direction. Going back here. So I connect to fast Ethernet 6. Actually, you can connect to any of the ports. I'm just connecting in there because, that's what it says. The same goes for PCB. Connect NIC of PCB to fast Ethernet 18. There. So this simulates the real equipment. Initially, it is amber, and then after some time, it becomes green. Green means that, hey, there is a viable network connection. But you still cannot ping it because you haven't given an IP address yet. We'll be doing it later. So what about switch to switch? Switch to switch, how is it connected? Let's have a look. For switch to switch, for S1, it will be fast Ethernet 1 connected to fast Ethernet 1 on S2. So let's follow that as well. Again, straight through cable. Click the straight through. Come switch, fast Ethernet 1 connected to fast Ethernet 1. Yes. So again, the color is initially amber, but after some time, it's going to be green. Okay. Now what I'm going to do is I'm going to configure my switch. If you remember, my switch 1 should be called S1. My switch 2 should be called S2. In my switch 1, I have to create a VLAN 1, which did with this IP address. And in my switch 2, I have to create a VLAN 1 with this IP address. Okay, so let's go and do that. There, you see, it's green. So let's go and create a VLAN 1 for this. This is my command line interface. Okay, I type enable. Once I type enable, it will take me to privilege exec mode. Then I type configure terminal, or short form, just type conf t. This will take me to the configuration terminal. Okay, now I type interface VLAN 1. I'm going to create a VLAN 1 interface and give an IP address. There. Now I'm inside VLAN 1 interface, okay, of my switch 1. So I type IP address 192.168.1.1. Subnet mask 255.255, sorry, 255.255.0. Okay. As you go through this course, you will learn all these commands. Okay. Don't be so hard on yourself. Eventually, you will learn them. And then no shut. There, the IP address has been given. Okay. So if I exit from here, I'm back in this place. I can change, you see my switch, I have to change the host name S1. You see, the switch is now called S1. The host name has been changed to S1. Okay, now show IP interface brief. Show IP interface brief. Sorry, exit. All the commands are stored inside, so you have to just use your arrow key. Okay, I'm doing something wrong over here. Okay, we can check that later. Okay, now that I've done this, I close my switch 1. Then I go to my switch 2. And do the same settings. Okay, I go to my command line interface. Again, for switch 2, enable conf t. And once I'm here, I type, let's first change the host name. Host name S2, correct? There, it's changed to S2. Now I type interface VLAN 1, because the switch also will have a VLAN 1. There, now I type IP address 192.168.1.2. So the subnet mask, oh sorry. Once I've done this, double check 192.168, yes, correct, subnet mask is correct. Then type no shut. There, this is also done. Okay. Then I can exit here and exit. Okay. I'm doing something wrong. So no, yeah. Show IP interface brief. If you type that command, you can see that you have to press enter to see everything. There, your VLAN 1 is 192.168.1.2. Okay, let's go and check the first one. Exit. Show IP interface brief. So on switch 1, my VLAN is 192.168.1.1. Okay, so all the IP addresses have been given. Now let's go and ping and see whether I can ping from PCA to my VLAN here, to my VLAN here, and to the PCB. So my VLAN here, VLAN 1 on switch 1, and VLAN 2, sorry, VLAN 1 on switch 2. So these names can be confusing. So just make sure that here also we call the switch display name as S1. So there's no confusion. There, S1. And here also I'm going to change my switch name to S2. So there's no confusion. There. Now open your PC1, go to your command prompt, and here you can start pinging. First, I'm going to ping my own PC. Remember, this is PCA. So I type 192.168.1.10. That was my PCA's IP address. So there we go. We get a reply. Okay. Sent 4 packets, received 4 packets. So the connection is good. We get 4 replies. Everything is good. That means the PCA's TCP/IP is working. We are just pinging our own PC. We have not established any connection with another device. Now I'm going to ping. Next step, I'm going to ping from PCA to my switch S1. Okay. So there we go. Again, I don't have to type everything. All the command history you can get in your arrow keys. Ping 192.168. My S1, switch 1 IP address is 1. Okay, it's pinging it. You see the first ping, okay, sent 4, received 3, lost 1. The first time it always, when it's looking for a switch, this happens, okay? if you run the program again, if you send the command again, the ping command again, you see, now it will send 4 and receive 4. No issues. Okay? Let's just run it again. Okay. Okay. This one clear this. Okay. So run it again. Now we can see that 4 packets are sent and 4 packets are returned. Nothing is lost. Just a second. Continuing with what we were doing, now I'm going to ping from my PCA to the other switch, which is my, from PCA to, if you remember, to my switch 2. Okay? So, sorry. Let's just close this so I can open a fresh one. There we go. Yeah, there we go. Command prompt again. Oh no, doesn't open a fresh one. Okay, never mind. So what I do is ping my switch to 192.168.1.2. Okay. Again, the first time I will lose 1 packet. You see, it's trying to look for Vlan 1 on switch 2. You see, the first one is lost, but the other 3 you get a reply. So if you do send another ping, now you get all the 4 packets. You get a reply, so that connection is good. Okay. And now the main test from PCA to PCB. Okay. So let's just send the ping. So remember, PCB was 11. There we go. You get 4 packets received. So that connection is perfect. Okay. So you have established a viable network, at least from PCA to PCB. Now let's do the other way around. PCB. Go to command prompt. Okay. And let's first ping PCB itself, 192.168.1.11. This is PCB IP address. Yes, TCP IP is working. Now I'm going to ping from PCB to its switch, S2. So ping to the VLAN 1 in S2, which is .2. Again, just like before, it will lose 1 packet and return 3, just like before. You see, reply. That is completely normal. The second ping, you will get full reply. Okay. Now, ping to switch 1. Ping again to get the 4 replies. Yes, everything is okay. Now, ping to PCA, which is 10. And the network has been established. Okay. In order to double check your network, you know, your ping, you go to your switch, go to your command line interface, and you can try the ping over here as well. Ping the switch itself. S1, what was the IP address? There, the IP address is right over here. See? 192, the VLAN address, dot 168.1.1. There, success rate is 100%. Now ping your PCA, which is 10 from switch S1. There, success rate is 100%. Now ping your switch 2. The first time, 60%. Second time, 100%. Okay. Now from here, ping PCB, which is 11, 100%. Okay. Same goes for your switch 2. Command line interface. I'm going to ping myself 192.168.1.2. 100% yes. Now I'm going to ping my switch 1. 100%. Why 100% and not 60% for the first time? Remember when you pinged from here, you got 60%. Why? Because you have already established a command, a connection in your previous ping from here. So when you ping again, it will show you 100%. So from switch 2 to PCA, which was 10, correct? 100%. So we have a viable network. So this is your task for today, my dear students. You have to establish this, and I have to be able to ping from here to here. No need to give passwords. You know, all those other commands that we have are decorative. What I want you to do is do this actual connection, and once you are done, show it to me, and I record that you have completed the lab, and then we are done. Okay? So that would be all you have to do. I'm going to now stop the recording.